Hello students. In this video, I want to explain about the terminal velocity. So basically here, I want to show you what happens when a skydiver is jumping from a plane. So when the skydiver jumps from the plane, there is a force that is the weight of the skydiver that points downward toward the center of the earth. And then, of course, as there is air surrounding the skydiver, there is a force due to the air that is a force of resistance. But at the beginning, the force of resistance is a very small force, so have a very small value. So since the weight is going to be greater than the force of resistance of the air, there will be then a net force pointing downward, because subtracting weight minus Fa, of course, you have a force that point downward that is a net force. Since there is a net force, then there will be an acceleration, and as there is an acceleration, then there is also an increase in the velocity. Eventually, as the velocity is increasing, the air resistance is also increasing, and eventually the magnitude of the air resistance will be equal to the magnitude of the weight. So when the weight and the air resistance are equal, now we don't have any net force acting here. So we have no acceleration, so we have a constant velocity. But usually when you jump from a plane, the value of the terminal velocity without a parachute is very, very high. So we can be talking, and you watch the video that I post, we can be talking about 50 meters per second or something like that. So that is a very high value. If you land at that velocity, you're going to die for sure. So what happens? You open the parachute, and when you open the parachute, now you have that the force of the air is in terms just larger because the force of the air depends, right, on the area, and we have a higher area because it's the area of the surface of the parachute involved here. So since now the force of the air is greater than the weight, we have now a net force in the opposite direction. So we have now an acceleration in the opposite direction, and we have the velocity of the person just as is falling down is decreasing until we reach again an equilibrium between the weight and the force of the air, because as the velocity is decreasing with this value decreasing, now this value, the air force, the force of the air is going to decrease also. So eventually W and Fa are going to be equal again, and you're going to reach again a new value of terminal velocity that could be in the order of 4, 5, 6 meters per second. So this is a safe velocity to land. This is basically what happens. Now, how do you calculate the force of the air? You calculate the force of the air using this formula, where you have the coefficient of shape, or uh, that means this coefficient that depends on the shape of the object. You have the area that is facing, the air, and you have the velocity. Now, when you reach the equilibrium between the W and the force of the air, you have that Fa is equal to W. So since W is mass times gravity, and you know that Fa is Ca Bt squared, when you solve for Bt, you have the square root of mass gravity over Ca. So with this formula, you can calculate the terminal velocity, of any object that is falling down. The only thing here is just to remember, well, in the presentation that I give you, I give that C is equal to 0.88 kilograms per cubic meter. This is for a person. If you have now different shape, you have a spherical shape, you have a cubic shape, you have the shape of a plane, etc. This coefficient is going to change, right? So it's going to have a different value. So with this, we can just do the calculations, and you can solve just any problem involving terminal velocity. Thank you.